Hello everyone, nice to see you again in our class. Today we are going to talk about life cycle thinking in energy and environmental systems. More specifically, electricity generation from a life cycle assessment or life cycle thinking perspective. In previous lessons, we talked about life cycle assessment. It's an environmental management tool or way of thinking that assess the overall energy use and the environmental impact of a process, a product, or an activity over its entire life, from the raw materials acquisition, production, distribution, usage, and also waste stage, and the recycling of the wastes and the final disposal. So we judge a system or a product from the entire life cycle perspective. According to ISO 14040 standard, life cycle assessment or life cycle thinking have 4 steps. One is goal and scope definition, the second is inventory analysis, and the third is impact assessment, and then is the results interpretation. Also, we talked about 2 different vehicles powered by different energy. One is fuel vehicles powered by gasoline or natural gas. The other one is electric vehicles powered by electricity. And we concluded that electricity is one of the most important factors affecting the environmental performance of the vehicles. And the electricity from, where is the electricity from, and also whether the electricity is clean or not. It's a very, very important factor affects the environmental behavior. So we are going to talk about the electricity generation from a life cycle perspective today. Today we are going to talk about 3 topics. The first one is, what is electricity and how does it come from? And the second one is electricity generation worldwide. Last but not least, we are going to talk about electricity generation from a life cycle assessment or life cycle thinking perspective. When talk about electricity, what's the first picture in your mind? It's a lamp, it's a television, a computer, or a cell phone, or some household appliance. What did you first get in your mind when we talk about electricity? Electricity is almost as we see, almost everything and everyone is dependent on electricity nowadays. Being one of the basic ingredients of the universe, the electricity is something that has revolutionized the way life is on this planet. Talking of all scientific innovations, electricity is by far one of the best things happened to the entire human civilization, and now we can't imagine a world without electricity. As we know that everything around us is made of invisible atoms that contain particles with electric charge, which is either positive or negative. The movement of electric charges creates the electric current, which drives much of the modern world. Okay, what is electricity? Electricity is a form of energy. It's the flow of electrons. As we all know that there is a model of the atom. All matter is made up of atoms. And an atom has a center called a nucleus. The nucleus contains positive charged particles called protons, and the uncharged particles called neutrons. The nucleus of an atom is surrounded by negatively charged particles called electrons. The negative charge of electron is equal to the positive charge of a proton. And the number of electrons in an atom is usually equal to the number of protons. When the balancing force between protons and electrons is upset by an outside force, an atom may gain or lose an electron. When electrons are lost from an atom, the free movement of these electrons constitutes an electric current, and then we get electricity. Electricity is a basic part of nature and is one of the most widely used forms of energy. We get electricity, which is secondary energy source, from the conversion of other sources of energy, like coal, natural gas, oil, nuclear power, and other nature sources, which are called primary sources. So electricity is a secondary energy source. And wind, solar, nuclear, and geothermal, something like this, are primary energy sources. In ancient times, many cities and towns were built alongside waterfalls, which is a primary energy source of mechanical energy that turned water wheels to perform work. Water wheels to perform work, we use the energy content in water. And also, people use windmills to perform work. This is a windmill, and people use windmills to perform work by using wind energy. However, beginning with Benjamin Franklin's experiment with a kite on stormy night, the principles of electricity gradually become understood. In the mid-18th centuries, everyone's life changed with the innovation of the electric light bulb lamp. Electricity had been used in arc lights for outdoors lighting. The lamp's innovation used the electricity to bring indoor light in our homes. Here, we will share you some interesting things about electricity. We have top 10 facts about electricity here, and you can also refer it in the internet. The first one is Benjamin Franklin and his historical experiments. Franklin did a historical experiment of providing lightning a form of electricity with similar properties. He just performed a simple experiment. For that, he tried out flying a kite in thunderstorm. Along with the kite, he also tied a key as well. His iron rod amazingly drew lightning down into his house, and every time there was a lightning, the bells would ring and the spark would illuminate his house. The second one is, do you know the speed of electricity? What's the fastest thing ever known to the science? Light? Yes. However, scientists are striving to discover the bodies which are even way faster than the light. The speed of light is still the only proven and ultimate speed. So, the electricity travels at the speed of light, which is more than 300,000 kilometers per second, making it the fastest speed of anything in this globe. Having said all that, the speed of electricity is actually determined by its conductor and the type of electricity. There are some types which have a speed of 0, while others move at the speed of light. So the speed of electricity depends highly on the conductor and the type of electricity. The third one is, do you know who invented the battery? Did you ever know that the man behind the invention of battery? If not, he is Alessandro Volta. He was the one to introduce for the first time that when we conduct two material streams made up of different material in the sulfuric acid solution, it makes a battery the source of electricity generation. Volta's voltaic setup was the first ever wet cell battery that produced a reliable and steady current of electricity. this is something about the battery. And also, do you know something about electricity generation? What are the sources that we use to generate electricity? Actually, there are many forms of energy sources that we use to make electricity. The main among them are water, animal manure, wind, and sun. But if we analyze and compare the power plants in the globe, about 26% of the world's total power is produced from coal, 20% from natural gas, 6% from nuclear, 10% from wind, solar, and geothermal, and only 2% of them from hydropower. So we have wind power, hydropower, solar power, geothermal power, biomass, and also some non-renewable energy form, for example, fossil fuels, nuclear power, and something like this. The fifth one is the first bulb ever. Credit for the first person to invent the bulb goes to Thomas Edison. We all know that Thomas Edison invented the lamp. And the sixth one is the property of electricity. We all know that electricity is non-renewable form of energy. It's a secondary energy. But some energy sources used for generation of electricity are renewable as well. The sources like wind, water, biomass, and solar are renewable sources of energy, and the renewable sources of energy have to be the best way to produce electricity. It's actually the greener way of generating electricity. We have some renewable energy to produce electricity like wind, like water, like biomass, like solar energy, and we will talk about it later. And the seventh is the magnetism and electricity. It is obvious true that the purpose of generator is to generate the electricity, but did you know the mechanism behind the generation of electricity? The mechanism is the conversion of mechanical energy into it's mainly mechanical energy into electrical energy. Originally, both electricity and magnetism was thought of as two separate forces, but its perception changed later on with the publication of a famous book by James Clerk Maxwell in 1983. It's the magnetism and electricity. And the eighth is the first use of electricity. In present day, we use electricity for various purposes. Do you know? Do you wonder what was electricity used for the very first time? Well, the first use of electricity was for nothing else but only for for living and domestic purpose. Even if look back the record history, the first practical application of electricity is Benjamin Franklin's lighting rod. And the next one, we have some study into some bioelectricity. What is bioelectricity? It's actually a nature use of electricity in human bodies, which we discovered by some scientist, saying he claimed that the medium used by nervous cells to pass signals from the muscles is also electricity. We use electricity to pass the signals in our bodies. When we think of electricity, we generally tend to visualize it as something out of human bodies, but science has proved that there is a form of electricity in our bodies and in every living creatures. Bioelectricity is undoubtedly one of the boldest innovations in science these days. And the next one is, it's an awesome force. Electricity is a basic but one of the most powerful forces of nature. The lightning shows how powerful it is. One lightning bolt has enough electricity to service 200,000 homes. With strong air current tear apart and positive and negative electric charges, lightning do happens, creating huge tension and eventually release a gained spark. So lightning is a very powerful energy forces. And then we are going to talk about how does electricity come from. We all know that we have some power plants. We convert some energy into electricity. For example, wind energy, solar energy, we convert them to electricity. But how does electricity come from? We use electrical generators to produce electricity. An electrical generator is a device that converts mechanical energy to electrical energy. Generally use electromagnetic induction. Here is a principle of the turbine electric generator. We have some kinetic energy sources. For example, steam, high pressure, high temperature steam, or combustion gases, flowing water or wind. We have some energy sources, and we use a rotor to receive this energy, and then we can convert this energy into electricity in a stator. Most power plants use a turbine to drive electricity generators. In a turbine generator, a moving fluid, for example water, steam, or combustion gases or air, pushes a series of blades mounted on a rotor shaft. The force of the fluid on the blades rotates the rotor shaft of a generator. The generator in turn converts the mechanical energy into electrical energy. Different types of turbines include steam turbines, combustion gas turbines, hydroelectric turbines, and wind turbines. We will discuss it separately. First is a steam turbine. A steam turbine has a boiler in which a fuel is burned. A fuel is burned here to produce some in a boiler to produce some steam, to produce hot water and steam in a heat exchanger. And then the steam powers a turbine that drives a generator. The steam produced from the boiler drives the turbine, and then the turbine drives the generator, and then we have electricity output. The second one is combustion gas turbine, which are similar to jet engines. The gas is burned. The gas or the liquid fuels are burned in the boiler, and then the produced hot gases drive the blades of the turbines, and then it drives the electricity generator. And then we also have geothermal power plants. We use geothermal to produce steam, the heat, the underground heat, the geothermal to produce steam. Maybe the temperature is not high enough to use water as the working fluid medium. We also use some organic fluid. Also, we call it organic Rankine cycle. We use the geothermal to produce steam, and then the steam powers a turbine that drives a generator. The heat source is from the geothermal, is the underground heat. We produce the steam, use the underground heat, and then the steam drives the turbine, and the turbine drives the generator. And then we have geothermal power plants. And also we have hydroelectric turbines. Hydroelectric turbines use the force of moving water to spin turbine blades to power a generator. In hydroelectric turbines, we don't use steam or don't use water. We don't use steam to drive the turbine, but we use the energy content of moving water. We use moving water to drive the turbine. Here we have hydroelectric turbines, and also we have nuclear power reactors. Nuclear power reactors use nuclear fuel rods to produce steam, and the steam powers a turbine that drives a generator. The heat source is from here, the reactor. We use nuclear fuel rods here, and then the heat is generated here, and we use an exchanger to produce some hot water or steam, and then the steam drives the turbine, and the turbine drives the generator, and then we have electricity output. And also we have solar thermal power plants. For solar energy, we have two kinds of utilization ways. One is solar thermal power plants. We use solar energy to produce steam. We centralize the solar energy to the tower, to the top of the tower, and then here we can produce hot water and steam to produce steam, and then the steam powers a turbine that drives a generator. We use the solar energy here to produce the steam, and then the steam drives the turbine. Here is solar thermal power plants, and we also have another kind of solar energy power plants. It's solar photovoltaic cells. Solar photovoltaic cells convert sunlight directly into electricity. They are used to power devices as small as wristwatches, and can be connected together in panels that are connected together in areas to power individual homes or form large power plants. Photovoltaic power plants are now one of the fastest growing sources of electricity generation around the world. The photovoltaic cells power plants is the fastest growing source of electricity in nowadays. And we also have combined heat and power plants, which may be referred to as co-generators. A CHP plant uses the heat that is not only converted to electricity, it's not only converted directly to electricity, but also for some heat supply, for example, for industrial use, for district heating, but also used for industrial processes heat or for space and water heating. CHP plants are among the most efficient ways to convert a combustible fuel into useful energy. Because of the power, electricity and heat co-generation, so we can improve the energy conversion efficiency of the plant here. Also, we have some storage systems. For example, pumped storage hydropower plants that uses the same types of hydro turbines that conventional hydropower plants use, but they are considered electricity generation systems. What does it mean? It means that when we don't need that much electricity in the mix, we can use electricity to pump the water from lower places to higher places, and then this is electricity storage. And then when we want more electricity from the mix, from the system, we can use this system again to produce some electricity to the system. It's called pump storage hydropower plants. We can treat it as an electricity storage system. And also we have wind turbines. Wind turbines use the power in wind to move the blades of a rotor to power a generator. Here we use the energy content in wind, and then the blade is driven, and then the turbine is driven directly from the wind. And also we have some new technology. One is ocean thermal energy conversion systems. Ocean thermal energy conversion systems use a temperature difference between the ocean water at different depths. For example, we have cold seawater at deeper places, and we have some warmer seawater at some upper levels. And then we can connect these two different depths, the water depths, and then we can get some steam or some driving force by using heat exchanger, and then we can drive power a turbine to produce electricity. We use the time difference between deep cold seawater and upper warm seawater, the temperature difference between ocean water at different depths. We use these temperature differences to produce steams and then to drive the turbine. We also have some other types of generators. For example, solar photovoltaic cells. We have already introduced it, and also we have internal combustion engines. Internal combustion engines such as diesel engine are used all around the world for electricity generation, including in many remote areas. They are also widely used for mobile power supply at construction sites or for emergency or backup power supply for buildings and power plants. Diesel engine generators can use a variety of fuels, including diesel, biomass-based liquid fuels, and biogas, natural gas, and some other fuels. Small internal combustion engine generators filled with gasoline, natural gas, or propane are commonly used by construction crews and tradespeople, and for emergency power supply for homes. Here are some internal combustion engine, or more specifically diesel engine electricity generators. Also, we have fuel cells, stirring engines, and thermoelectric generators. For example, here is a fuel cell. This is a stirring engines. This is the principle of the thermoelectric generators. When we have temperature differences between the hot side and the cold side of a semiconductor, we can have electricity output by using thermoelectric generators. Okay, and then we also have some energy storage systems for electricity generation. Energy storage systems for electricity generation include hydro-pumped storage, which we have already discussed, and also compressed air storage, and electrochemical batteries and flywheels. These energy storage systems use energy. They use electricity to charge a storage facility or devices, and the amount of electricity that they can supply is less than the amount they use for charging. So you may imagine why we use these energy storage systems. Just as we said, when we don't need that much electricity in the society, we can use the electricity to we can introduce the electricity to the storage systems. And when we need more electricity than the generation amount, we will use the storage system to produce electricity, and then we can have more electricity. Therefore, the net electricity generation from storage systems is counted as negative and avoid double counting electricity used for charging the storage systems. Here we have the hydro pumped storage systems. We pump the water at lower places to the higher places when we don't need that much electricity. And when we need more electricity from the system, we can use the water here to produce more electricity. And we have compressed air storage. We use the electricity to compress the air, and if we need more electricity from the system, we use the energy content in the compressed air to produce electricity. And we have flywheel storage system. It's also an energy storage system. Okay, here we have talked about the topic, what is electricity and how does it comes from. And then we are going to share you something about the electricity generation worldwide. Firstly, this is electricity generation worldwide from 1990 to 2021. As we can see, the total amount of electricity generation increased gradually in the past 30 years. But we can see two obvious declines here. The first one is in 2009. The first annual electricity generation amount declined at 2009 here. The main reason is due to the global financial crisis in 2009. And also we have a decline here in 2020. It's mainly due to the coronavirus pandemic these days. The total amount of electricity generation in 2021 reached 28,000 terawatt hours in 2021. And if we look into the data, the electricity generation by different kinds of fuels are presented here. As we can see, around 16% of the total electricity generated worldwide is from fossil fuels, and about 35% of the electricity generation is from low carbon fuels. For example, nuclear power, hydropower, wind power, and solar power. And for geothermal energy and biomass and other renewable energies, is only accounted to around 3%. And other, we have less than 1% energy sources. More specifically, we can see the worldwide electricity generation from coal is 36%, from oil is 2.5%, from natural gas is 22%, and from nuclear power is around 10%, wind power is 6.5%, and solar energy is 3.6%. And hydropower is 15%, and some other energy sources. We can see the tens of shares of the electricity generation worldwide. For fossil fuels, it's a little bit steady in the past 30 or 40 years. For low carbon fuels, it's also the shares of low carbon fuels is also quite steady, and for geothermal, it's steady, and for others, it's less than 1%. And for specific fuel, we can see the shares of coal declined in recent years. In the past 10 years, it declined gradually in past 10 years. For oil, it declined from 10% to less than 5% in the past 30 or 40 years. For gases, it increased from 50% to around 25% in the past years. And for nuclear power, the share we can see here is the shares. The shares decreased from 50% to 10%, and for hydropower, the shares declined from 20% to 15%. What is worth mentioning that the renewable energy power source, which is wind and solar energy power source, increased gradually from 2000 to at approximately 0 in 2000 to 10% in 2021. For other renewables, it also increased gradually in these years. It's the shares of the energy sources, electricity generation from different energy sources. We can see here in the highest shares of low carbon fuels occurs in 1995. It's the highest share is 36% in 1995. It's 60%. The annual share of fossil fuels in world electricity generation becomes quite steady in the past 30 or 40 years, from 63 to 61. It's quite steady. And also, we can see here we are talking about the shares, and then we are going to talk about the absolute values. The shares may be decreased, but the absolute values of most of the electricity generation from different fuels are increasing. For example, here is all fuels. It's the total electricity generation from 1985 to 2021. We can see increasing trend of the total amount of electricity generation. But as we mentioned previously, in 2009 and in 2020, we have a slight decline of electricity generation due to the financial crisis and also due to the pandemic of the virus. And for fossil fuels, we can see at the beginning of the chart, we can see gradually increasing is the obvious increasing is here. And then in the past 5 or 10 years, the total amount of electricity generated from fossil fuels are become quite steady here. And for low carbon fuels, for electricity generation from low carbon fuels, for example, nuclear, hydro, wind, and solar, we can see the share of the low carbon fuels. It's quite steady, between 30% to 40%, and even there is a decrease here in 2000 and 2009. There is a decrease here, but for the absolute amount here, we can see the electricity generation from the low carbon fuels increased gradually in the past 30 or 40 years. Increased gradually. And for more specific fuel types, we can see coal is one of the most important, one of the dominant energy sources of electricity generation worldwide. It increased gradually in the past 30 or 40 years. And oil decreased in recent years, and the gases increased gradually in the past years. And also we have nuclear power. It increased at the beginning and then becomes quite steady in the past 20 years. And also we have hydroelectricity. We can see also For hydroelectricity, the shares is decreasing, but the absolute values are increasing in the past 30 or 40 years. And we have some renewable energy electricity. It increased dramatically from 2000 to 2021. The increasing rate is quite high here. And we have the annual change of world electricity generation. We have the most obvious difference is here in 2009 and also in 2020. We have two declines of the total amount of electricity generation here due to the financial crisis worldwide, and here from the versus these days. And when it comes to some different countries, firstly, we will share you something about China. China increased its electricity generation amount annually from 2000 and 2020. As we can see, we have some different types of energy sources for electricity generation, like coal, natural gas, nuclear, hydro, solar energy, and wind energy, and other kinds of energies. The electricity generation in China increases gradually in the past 20 years. Even in 2009 and in 2020, we have an increase in the total amount of electricity generation in China. And also, China has steadily increased its electricity generation over the past 20 years, reaching 7,600 terawatt hours in 2020 from 1,218 terawatt hours in 2000. Even the versus in recent years and in 2009, the financial crisis worldwide, China also has increasing electricity generation. In 2020, China still expanded its electricity generation by 5%. In 2021, China's government issued its fifth five-year plan for national economic and social development. The plan sets out China's strategy for industrial planning and policy through 2025, and prioritize China's low carbon and carbon neutral purpose. The plan sets numerous goals, including to achieve its goal to reach peak carbon emissions by 2013, after which its target is to have carbon emission decline, and also to become carbon neutral by 2030 and 60. Also to reach a 39% of non-fossil fuel share for electricity generation by 2025. So as we can see here, more than half of electricity generated in China is from coal, which means coal is still the most important electricity or energy sources in China. Here we can see China has been increasing the share of non-fossil fuels in its electricity generation. The renewable energy share is increasing steadily in recent years. In 2020, China generated 4,800 terawatt hours from coal-fired power plants. A 16-3 share of China's electricity generation. Coal shares 63% of China's electricity generation. However, in 2000, the share of 77% of China's electricity generation is coal. So we have decreased it dramatically from 77% to 63% from 2000 to 2020. The share of the coal decreased from 77 to 63. In the past 20 years, non-fossil fuels, including hydroelectrical, wind, and solar generation, grew 27% of China's electricity generation mix. We can see the non-fossil fuels, the electricity generated from non-fossil fuels increased by 27% in the past 20 years. Not by 27%. Increased by 10% from 70% to 27% in the past 20 years. Solar energy has been the fastest growing generation source and grew by an average of 43% each year from 2015 and 2020. Solar energy accounted for 6% of China's electricity generation in 2020. Despite the carbon goals in China's 5-year plan, coal will remain an important fuel in China's electric power sector in the near term. In total, China approved 46.1 gigawatts of coal-fired plant projects in new launched in 2020. Natural gas, however, is replacing some of the coal-fired capacity in eastern region of China, where power demand is higher than the rest of the country, and the northeastern region, where stricter environmental regulations have reduced the coal-fired power plants electricity generation. China remains the world's most populous country, and with a population of 1.4 billion in 2020, and has a fast-growing economy. Our data shows that in 2020, more energy was produced and more energy was consumed in China than in any other countries. We expected that China's energy demand will continue to increase.